is this? My God. One important thing to note is that it's not always possible to know which good gives you the most satisfaction. Usually we do so through trying. For example, if you take a particular drink, you're usually trying to see if you like it or if you like a different flavor of it. But in this chapter, we have the assumption that the consumer knows everything they need to know to make the right decision, and that's our last point here. But coming back to the first point, we have to assume that there is a huge number of consumers for any particular good, because it's not always the case that a good will have a huge number of consumers, depending on demand and how well a good is advertised and many other factors. But in this case, we assume that there is a huge number of consumers. We assume also that the power of negotiation of price does not exist. That means the level of the price of a good is set. It can't go up and it can't go down. So if they tell you that the price of good X is 2 kwacha, then it stays that way. There's no way to change it, reduce it, or increase it in this particular case, which of course in real life isn't always the case. It's possible to negotiate for certain things, but this time we assume that we can't negotiate for the price. Thirdly, the actions of the consumer have no effect on the choices of other agents. I tried to highlight on this in our previous lesson, but now that I consider it, I looked at this in a different light. The important thing to get on this point is that producers can change certain things to their goods in terms of the choices that they make. For example, if they see that consumers are buying less and less of a good, they may choose to reduce the price of the good to make it more affordable for people. But in this case, we assume that the producers or any other agents will not do anything no matter what the consumer does or does not do. That also goes to solidify the fact that things like price are fixed. So we have two sides here to understand. For the one thing, a consumer can't negotiate for the price of a good, and secondly, the other agents will not change, will not make any decisions or change any decisions based around what a consumer does. Are we together so far?
Yes.
Yes.
Okay, no questions? Everything is clear?
Oui, c'est clair.
Okay, thank you. So the last point, which I highlighted already, is the fact that all of the needed information is available to the consumers, hence there is an absence of risk. There is no risk factor. So it's not possible for a consumer to make the wrong decision. Okay, so just keep these things in mind. They don't really have a huge bearing on how we'll be doing our calculations and all of that, but it's important to keep them in mind. They may come they may come as exam questions and things of that nature. Okay, so another thing to consider in this case is that satisfaction is a subjective thing. This is an important point, because when we get to the next section, you will find that the people who came up with that theory will say that it's not possible to quantify satisfaction. In this case, we have something like total utility, which is quantified, but in that case they tell us that it can't be quantified, so we have to find something different. The first theory we're looking at is the theory of cardinal utility. In this case, satisfaction or utility can be quantified, but when we move to ordinal utility or utilité ordinale, we find that it can't be quantified. They say it can't be quantified because it's subjective. It changes from individual to individual, but for the moment we'll be focusing on cardinal utility, that tells us that it is possible to quantify utility or satisfaction. Are we together so far?
Yes.
Okay, thank you. Alright, so another thing that we will consider in this chapter is the individual demand of a good, because it won't be the same from one good to another. What we will do is that we will analyze the evolution of the above stated equilibrium, the point where the consumer has the most satisfaction. We will observe how that changes when one of its factors vary. There are two factors to consider when looking at the equilibrium. The first one is the price of goods, and the other is the budget. So when either the price of a good increases or decreases, we see how the demand of a good shifts, whether it decreases, or increases. And also in the case where the price remains the same but the budget is increased, we see how the demand of a good will change, whether it will decrease or increase. And then we'll have to look at how sensitive demand is, like how will it react to these changes? Is it a really big reaction, or is it just a small one? So to do that, we're going to use what we call elasticity coefficients, and these help us to measure the capacity of reaction of demand to particular changes, in this case changes to price and to budget. That'll be at the end of this chapter. Is that alright?
Yes.
Okay.
Yes.
Alright, so in the last lesson we also tried to introduce cardinal utility a bit, so that's what I did here, and I didn't include the calculation so we could do them together. Alright, so now we're dealing with cardinal utility. I created this formula here to help you remember, just to differentiate between cardinal utility and ordinal utility. So when you think of cardinal utility, you should think of the two laws of Gaussen. In the previous lesson, someone asked me what that means or who that is. It's basically just a person who was doing research in terms of satisfaction and things of that nature, and he came up with two laws that we use to observe cardinal utility. So the first law is the law of diminishing or decreasing marginal utility, and today, in what we appointed for today, we're going to look at exactly what that means. The other one is the law of equalization of weighted marginal utilities, la loi de l'égalisation des utilités marginales pondérées, and I won't go into that. We'll see it when we finish this section. Alex, how much time do I have?
3 minutes.
3 minutes. Okay, so in that 3 minutes, let me just finish up this summary, and when we come back, we'll start with the actual lesson. Excuse me a second. Sorry, my throat was dry. To take some water. Okay, so in the first law, diminishing marginal utility, we have two important definitions to consider and understand. The first one is total utility. We have to understand what total utility is for us to understand what marginal utility is. I gave this definition previously, but I think it's better when you can actually see it now. So total utility is the aggregate satisfaction that a consumer receives through the consumption of a specific good or service. And then the word aggregate implies that you are combining a number of elements, and we'll see just what that means as we go into total utility. So yeah, total utility is the aggregate satisfaction that a consumer receives through the consumption of a specific good or service. And when you say aggregate, it means you're combining a number of factors to have this total utility. Utility total is noted as ux, and its basic formula is ux is equal to f of x. It means it's a function of sorts, and we'll see that later. Are we together so far? Anything that needs to be clarified? Are we together?
I have a question.
Yeah.
Shoot.
You said the total utility is noted as ux, as its basic formula is ux is equals to. What's this basic formula for? What are you calculating for here? You're calculating for the total utility?
Exactly.
Oh, okay. All right.
Yeah. I remember in the previous lesson I had mentioned that when you're given a table of values for utility total, it's given to you usually. So you don't have to worry much about this formula. It's just that it was used to create the formula for marginal utility. Sometimes you have to calculate it, but not all the time. But yeah, so usually they give you the values. Is that okay?
Yes.
Okay.
Yes, 30 seconds.
30 seconds. Okay, I'm asking for 1 more minute just to explain this last part here. Then we can go on a break. Okay. So in the previous lesson, I mentioned that marginal utility is just a part of total utility, or it's just a small thing that explains total utility. So its definition here is that it measures the satisfaction received from consuming an additional unit of a good or service, thereby causing total utility to vary. So it's like you already have total utility, then you already had good x, then you have another small part of it, and you see how total utility will change. Again, we'll see what this really means later. So this is to say that it helps us to observe how total utility of a good changes when we consume another unit of that particular good, and it's noted as UMX, utilité marginal of x. Sometimes it can be UMY, depending on what your good is called. So generally for total utility it's UX, but if they tell you that your good is Y, then it will be UY. If your good is P, to be UP. But yeah, generally that's the case. And then marginal utility is UMX or UMP, UMT, whatever it will be. That's the case. So yeah, I think that's it. I hope this part is clear. We can take our break. Alex, you tell me when to come back, and then we'll continue from there. Thank you for your attention so far. Huh.
Oui, madame, est-ce que vous êtes là?
Oui, monsieur. Je suis là. Okay, so we can continue then.
Ah, d'accord. Oui.
Okay, thank you, Alex. Alright, so please confirm if you can still see the screen.
Yes, but I have a question.
Go ahead.
Yes, so we find total utility and marginal utility under cardinal utility.
Exactly. That's all? You were just confirming?
Just confirm.
Okay, alright, good. So yeah, the section we're under is cardinal utility. Then we have to consider these particular definitions here and how to calculate them. Alright, so like we said, utilité marginale is noted as UMX or UMYP, whatever your good is named at that particular moment, but it's just UM. And then the formula for it is the variation of total utility over the variation of the consumed quantity of the good. So when you see, like here exactly, UX, you have your total utility. But when you see just X alone, it's the quantity consumed of the good. When you see a small x. When you see a big X, it's just telling you that this good is named X or Y or anything. This, the small letter, just corresponds to the consumed quantity. For example, you can have your good X and then you consumed 3 of them, and then later you consumed 4 of them. So that there is your variation. You have this as X1 and X2. Don't worry, I'll explain this just now, that this is actually the main part of today's lesson. So this variation down here is basically just the change in the quantity you consumed, and then for every quantity you consume, the total utility will change. So you also have to see the variation of total utility. So say, take for example, when you had 3 quantities of good X, your total utility, your UX, was 8, and then when you had 4, your total utility was 10, and so you have to use those to calculate. But yeah, we'll get more into that today. Then one important part of this to note is that the bottom part there, the variation of the quantity you consume, is always equal to 1, and that can be proved. It's just a rule you should keep in mind. Whatever the case, it will always be 1, whatever happens. And yeah, we'll see that today. So when you try to rewrite the formula, you have this. In this case, the top part remains the same, however this bottom part here becomes 1 because it's always equal to 1. But it's always important to show your working. So basically when you write, you'll start with this part here and you will show how and why it's equal to 1, which is what we'll see today. Are we clear so far?
Yes.
Yes.
Okay, thank you. So we're done with this part here. We can now go into today's lesson. So after consulting with a couple of other people, we concluded that using a PowerPoint might be more useful for you guys. So we'll see just how beneficial it is for your learning experience. Alright, so under Cardinal Utility, like we mentioned, we have 2 laws to consider. The first one being the law of diminishing marginal utility, and we'll see just what that means. So our first point here pretty much defines just what marginal utility itself means. Then we'll get into the next slide that helps us to understand what diminishing marginal utility. So I already gave a definition of marginal utility, so I assumed you might be starting from here today, so I felt it fit to put it here as well, but we'll still go through it. So marginal utility is the utility or the usefulness or the satisfaction that you have when you consume an additional unit of a good, as we mentioned before. And then we also have to consider that marginal utility of a good is the increase of the utility, the total utility, the increase of the total utility obtained from the consumption of that good. So like we said previously, when you consume an additional quantity of a good, it will increase the total utility that it has. For example, in the previous document I stated, for example, if you have 3 quantities of good X, you had 8, and when you have 4, you had 10, so it will increase generally. And this is also if the consumption of other goods remains constant. So there will be other cases where we'll look at 2 or 3 goods simultaneously, but if as the consumption of those remains constant, the consumption of one particular good may change. but for now, just keep in mind we're dealing with only one good. And so, coming to our third portion here, marginal utility, UM, measures the evolution of total utility to the margin. That's to say that the additional quantity you consume may be a very small amount. This serves us well because we're trying to understand how much it can change. So we'll usually consider very small amounts. So when we're considering marginal utility, we consider it to a very small margin, a very small variation in the quantity that you consume. Would you guys like for me to go through this in French, or are we fine so far? Are there any questions?
No questions so far.
No questions. All right. So we'll go to our next slide then, looking at what diminishing marginal utility means. La loi de l'utilité marginale énonce que l'utilité marginale d'un bien a tendance à diminuer à mesure que l'on en accroît la consommation. So this tells us that as you are looking at marginal utility, at some point it will begin to decrease as you increase consumption. For example, if you take the same example I gave, you consumed 3 quantities of X, you had 8, you consumed 4, and you had 10, maybe you consume 5, and you have 12. Then at some point it will begin to decrease. Actually, before that, say you consume 6 and you find that the utility of the good is still 12. That's the thing we call the point of satiety, and we'll come back to that. But after you reach that point, it will begin to decrease. You'll find that it goes back to 10, 8, here and there. So that's a very broad general explanation, but as we go down in this lesson, we'll understand what that means. The basic idea is that after a while, your marginal utility will begin to decrease. And so this also means that your total utility will decrease at the same time. For example, a person is in general very satisfied when they possess or when they get one phone, like the first phone. But then when you get another phone, the satisfaction is not really the same because you have pretty much what you need, and it's less when you get a third phone. That's our example here. So usually you get a phone because you need it, and so as you buy more and more, it becomes less satisfying or useful to you because the usefulness you need is fulfilled by one phone unless you have other needs, but generally one phone is sufficient for one person. Are we together so far?
Yes.
Okay, thank you. So at the point where you have reached the point where the usefulness is met, where like you have one phone, it meets all of your needs, or you take a particular good and it completely satisfies you, you have reached the point of maximum satisfaction, which is the goal of the consumer, as we mentioned before. And so we call this point again the point of satiety. Now, at the point of satiety, utilité totale reaches its maximum point. Like we said here, the satisfaction is at its maximum point, and then marginal utility will come to 0. So we'll see at that point, in the previous example, I mentioned that you may come to a point where, for example, you increase the quantity you consume of the good, but the marginal utility remains the same. Say you reached, maybe you consumed 4, and you had a utility of 15, then you consumed 5 and you still had a utility of 15, and then after that it begins to decrease. But marginal utility at that second point, when you consumed 5, the UMX will be 0, and we'll see that as we go down. There's an example I'll give. But know that at the point of satiety, your marginal utility is at 0, while the total utility has reached its maximum point, and this means that both of them will begin to decrease. If UMX is at 0, then it will now go into negative numbers, and then if total utility is at the maximum point, it now begins to decrease in number. And at this point, the consumer reaches their point of equilibrium, which we already talked about before. Any questions so far? Anything I need to clarify again? Guys, are you with me? Are you following?
Yes.
Yes.
Okay.
Yeah, it's clear. It's clear.
All right. Thank you. Please respond, yeah, so we can move together. Thank you. Okay, so coming back. So yeah, these are the points to consider. At the point of satiety, total utility is at the maximum point, marginal utility is null or at 0, and the consumer reaches the point of maximum satisfaction. And then after the point of satiety, the total utility now begin to decrease, and then the marginal utility will become negative, and then the consumer is less and less satisfied by a good. Okay, so we can proceed now. Here's an example. We looked at this in the previous lesson, but I thought that adding these little values here would help us to understand better and how to apply this into our formula for marginal utility. So like I said, when you have the small x here, it refers to the quantity consumed of your good. The big X is your good itself. It can be Y or T or anything, but yeah. And then, like we mentioned earlier, total utility is referred to as UX, UY, anything of that sort. So in our formula, we have the variation of total utility over the variation of the quantity consumed. It helps us to have these values here. So before we get into the calculations, let's just observe this table. So when this person consumed one quantity, the total utility was at 8. When they increased to 2, it was at 12. At 3, it was 14. At 4, it was 15. And at 5, it was 15 again. So I mentioned previously that there will come a point where you increase the quantity of the good you consume, but the total utility remains the same. This point here, where we are 5 and 15, that's your point of satiety. This is the maximum that a person can have. So say this person bought a drink, a particular drink. When they've bought five drinks of the same nature, then they've reached the total utility. If they buy any more, they'll become less interested in it. Is that okay so far?
Yes.
Yes.
Okay. So then you notice as we go down, now that the total utility has begun to decrease. At 6, it's 14, which is similar to the way it was at 3. And at 7, it's 12, which is similar to the way it was at 2. So generally, it will decrease until it comes to 0. So I hope we've understood how to read this table. It's a pretty simple illustration of what total utility really looks like. I think it's one of the best representations that there is. Then in our next slide here, we have a graph that shows us the evolution again of total utility. So at the bottom here we have the consumed quantity, and here we have the total utility, so it's an XOUX plane. So you see, from the consumed one here, it's generally increasing, and then at 4 it kind of stops, and then here it's kind of straight because the standard is the same thing, and after that point it decreases. So this part here corresponds to this part here, 5 and 15. So once you get to the point where you have changed the quantity you've consumed but the total utility remains the same, you have reached your point of satiety, the point where you've had your maximum, you've had enough, and then after this point it begins to decrease because you're less and less satisfied. Okay so far?
Yes.
Yes.
Okay, cool. So we're almost to the end of this lesson. The next thing we'll look at is just how to calculate marginal utility. I tried to give a broader overview so it's easy for you to follow. So what we have here, this diagram here shows us the evolution of marginal utility of this particular good we have been consuming. So I want to show you just how to replace the values into the formula. So again, here's our formula here. Marginal utility is equal to the variation of total utility over the variation of the quantity consumed, and as mentioned before, this part here, the variation of the quantity consumed, is always equal to 1, and you'll see that that's true as you observe these observations. So when I was studying this my first semester at the NCG, it wasn't very clear to me why this value was 8, because I hadn't applied the formula. It didn't really make sense, because this is something that requires you to put in your current value and put in the previous value. But if you look at the table that we have 8 here, but there's nothing before it. So it's, how is it possible for you to calculate marginal utility when you don't have the sufficient values? And we'll basically look at how possible that is. So I began to replace here. When finding the first marginal utility, you have ux1 minus hold on, this is incorrect. Give me a second. Let's see. Voila. Let me just correct this here as well. And here. Are we still together so far while I'm correcting this issue?
Yes.
Yes, 1 minute remaining.
1 minute. Okay. Alright, so we'll just look at this, how it was replaced here, and then we'll go on our break. Alright, so in this table I showed you that these values correspond. When you have x1, it's your first value here, and ux1, it's your first value here, x2 is this one, and ux2 is this one. So for calculating the first marginal utility, you have ux1 minus ux1 minus 1, and then you have x1 minus x1 minus 1. I mentioned previously, when you see something like this, a minus symbol down here, it means you're going to the previous value. So you do your petit calculation here, petit calcul. You have ux1 minus ux0, and then you have x1 over x0. So we go back to our table. We definitely have x1 and ux1, but we don't have ux0 or x0, which is logical, of course. But when you see something of that nature in terms of this, just know that it's equal to 0. when you see ux0 and you have a table like this where there's no ux0, it's just equal to 0. So here you have 8, which is our value here, minus 0, and then 1, which is our value here, minus 0, and your marginal utility will be equal to 8, which is the same as the total utility. Is that part clear before we go on our break?
Madam, why don't you write here 0 minus 8 and then down there you also write 0 minus 1? Because 0 is the first value. It will mean it's the first value there in the table. If there is no first, yeah, I guess you understand what I'm trying to say.
Yeah, I understand you. I guess in this case I'll have to refer to the previous one, I mean the second one. You see that here we have ux2 minus 1, which is basically ux2 minus minus ux1. So when you go back to the table, you have ux2 here, which is 12, and x2, which is 2, and then the one before is 8. So in our formula, this first value here, it's in terms of the current value dealing with. It's a case where you are subtracting the first value from the second one, not the inverse where you're subtracting the first value from the second one. In the question that you asked, like you said, you're right, the first value would be 0 and the second one would be 8. But if you follow the system of subtracting the first one from the second one, it will be 8 minus 0. You're subtracting 0 from 8. So you're using this case. Say there's 0 here on top. 0 is your first value, but you are subtracting it from the second value. Even in this case, for 8 and 12, 8 is the first value, but you're subtracting it from the second value. So it's 12 minus 8, not 8 minus 12. Does that make some sort of sense?
Yes, madam.
Okay. Alright, so if that's clear, we'll go on our break. Then Alex, you tell me when to come back.
Yes, madam, we can start so at 11:20 we have another break.
Alright, sure. Okay, so we'll come back. We'll go through this first part again just to be clear on how to replace. So as I explained to the previous question, you will take the second value and use it to subtract the first value. You subtract the first value from the second value. In the case where we had 0 and 8, it's 8 minus 0. And in the case where we have 8 and 12, it's 12 minus 8. In the same way here, we have 1 minus 0, and then later we'll have 2 minus 1, which I've shown here. So in the same way that I showed on this part, it's basically just a case to help you see how to replace it. So here we have ux2 minus ux2 minus 1, and we have x2 minus x2 minus 1, which means we have ux2 minus x1 and x2 minus x1. So here we come back, ux2 is 12, we have ux2 minus ux1, so 12 minus 8, and we have x2 minus x1, so we have 12 minus 1. So we come back here, it's 12 minus 8 and 2 minus 1, and our value is equal to 4. Are we together there?
Yes.
Yes.
Okay. So yeah, I wanted to just do these two here to show the difference, and then you use the same system going down. So you see on the diagram we have here, they continue to replace the values. You have 2, and then here you have 1. So you see that marginal utility is actually decreasing. In a case where here total utility was increasing as you went down until you reach the point of satiety, marginal utility is actually decreasing as you go down. So as we mentioned previously, when you reach the point of satiety, your marginal utility will be equal to 0. It will be null. So let's try to confirm this situation here. On when you come to the point of 15 in your replacement, you have 15 minus 14 and 4 minus 3, which is expressed here, 15 minus 14 and 4 minus 3. So your marginal utility is now at 1, when here in total utility it's still the same value, it's 15 and 15, but here it's 1 and 2. So marginal utility is still decreasing, even though total utility has come to a point where it's constant. But after this point, it begins to decrease. So you go down to your next values. You have 15 minus 15 and 5 minus 4. So obviously 15 minus 15 is equal to 0, and then you have 1 at the bottom, but 0 divided by anything is still 0. In analyze, you'll find the rule that 1 divided by 0 is undefined, just to make note of it, but 0 divided by 1 is always equal to 0. So if you've observed from the beginning, the value at the bottom is always 1. 2 minus 1, 1. 3 minus 2, 1. 4 minus 3, 1. 5 minus 4, 1, even in this case. But 1 going into 0 will give you 0. So when you reach this point, you realize that you have reached your point of satiety. You have reached the maximum satisfaction. So UM5 here, it's equal to 0. When you go to X5, it's 15 on total utility. So it's a repeat of this part generally. So okay, so let me track back before I confuse myself and you. Total utility, when you see these values repeated, you know that you've reached your point of satiety. And when you come to marginal utility, when you find that it's 0, you've come to your point of satiety again. Is that clear so far?
Yes.
Yes.
But this
Very
calculation,
clear.
are we trying to prove the first law of Gaussian, which is the diminishing marginal utility, or maybe these coordinates are going to use them somewhere, or these numbers?
No, your thinking is exactly correct. We're proving that marginal utility is diminishing.
Okay.
Alright. So from this point, you now begin to observe that you're going into negative values, which further proves the point that marginal utility is decreasing. In the same way, after this point on total utility, the values become less and less. So yeah,
I have a question.
go ahead.
When you go back to that table, kindly go back to that table.
This one here.
Yes. So when you see that the total utility is the same at 2 points, is it possible for the total utility to be like constant, maybe 4 times, but the quantity, the consumer like keeps on increasing on the quantity, but then the total utility is constant for about 4 times? Is that possible?
No, that's not possible. How do I best explain this? The reasoning behind the fact that it will only occur 2 times, it's the fact that at 4 you've reached the maximum total utility. After that point it becomes standard. I don't know how best to explain this. I think the best way to get it is just to know that it only repeats itself 2 times. Only 2 times. Because after that point it begins to decrease. It can never be a point where it repeats itself 4 times, because immediately after the second point it begins to decrease. That's always the case. I hope that's somehow clear. I know there's more reasoning behind it, but I won't lie to you and say that I know everything about this particular course. So yeah, the best way I can explain it is that way.
Alright, thank you.
Okay, you're welcome.
And then I just want to see again the graph again.
The graph? Alright, here you go.
Yes, and then why are we saying that on 0.5? That's
Instead of
what
0.4.
Instead of 0.4.
Yeah.
What's again?
It's basically the same reasoning, because immediately after 0.5 it begins to decrease. That's why it's the point of satiety. It can't be at 4 because the next one will be the same. So it doesn't really prove that the utility is decreasing, but it's exactly after 0.5 that it begins to decrease, and that's why it's the point of satiety. I hope that makes sense.
I have a question on that same one.
Shoot.
You said the maximum point it has attained is at 4, right?
At 5.
Oh, okay. Alright then, it's fine.
Alright. Okay, any more questions? It seems this part is a little bit shaky. I remember I also had a bit of a problem with it when going through this in my first semester. Any more questions? Okay, so I assume that the silence means no. Yeah. Inshallah, hopefully the professors at the school might explain this more, but I doubt it, because they'll explain it just the same way. I think a basic rule to understand it is just that immediately after the point of satiety it will begin to decrease. It can't be at 4 because the next one it's still the same value, but after 5 it begins to decrease. So that's what makes it the point of satiety. Let me go back to these rules here. Yeah, so after the point of satiety, the total utility decreases, marginal utility becomes negative, and the consumer is less and less satisfied. So you keep these 2 points in mind. So just after that point, UX begins to decrease. It now becomes what you see here, 14 and 12 from 15, and then UMX becomes negative. So the same right here, just after 0, it becomes -1, -2. So for you to know the point of satiety, you know that just after this point, it begins to decrease. I hope that's a bit clearer.
Yes, so in an exam, is it possible to just to draw the graph or maybe just to find
It depends on what they'll tell you. Yeah, it depends on what they'll tell you. I haven't seen any other past papers, but for the ENCG in Phys, usually they'll ask you to present a table of total utility, and then after you find marginal utility, they'll ask you for a table of marginal utility, which I'll show after this, and then they'll ask you for a graph. So you do all three at the same time. But it depends on the question. Sometimes they won't ask you to present the graph, just the table. Sometimes just the graph and not the table. So it just depends on what they'll ask you. Excuse me. Yeah, but usually the case is that they'll ask you to show the table of total utility, the table of marginal utility, and then the graph of total utility, also the graph of marginal utility. So yeah, it can come, but yeah, it just depends on what they choose to ask you. So it's important to understand how everything works. Is that okay?
I have a question.
Go ahead.
Since you said they'll tell you to draw a table of total utility. How do you find the total utility from this formula F then X? What does the F?
That one, don't worry about it. Don't worry about it. It's a case where they'll give you, this is something I want you to do, they'll give you something like this. So the value is already there. They just want you to present it like this in another format. Just show that this is the quantity consumed, this is the total utility. Okay, so it will come like this, and then they ask you to show it like this. Again, it's yeah, it's more likely that you have marginal utility, but it can come. Yeah, so that's the thing. Any other concerns?
No.
Alright, thank you. Okay, so after we've understood this part, we can now draw up the table of marginal utility. So you see that the quantity consumed still there remains the same, but now you just input the values that you found here. Basically in the same way to show in a better way how it progresses. So you have at the first point you have 8, second point you have 4, third point 2, fourth point 1. But then at the point of satiety it comes to 0, and immediately after that point it becomes negative, as we've stated before. Is that part clear?
Yes.
Okay, so I have a small exercise for you guys. I'd like for you to calculate the marginal utility here. Would you like to see the formula first before I leave this part? Basically, I just want you to replace these values in the formula and find the answers. There's silence.
Yeah, it's fine with that.
Okay. So I don't know if you've taken note of the formula. You can just get this part here. I don't know if it's clear enough. It's better when it's white. This is a problem. Can you guys see the formula? Or have you taken note of it since our previous lessons?
Yes.
Okay, so I can go back to the values now?
Yes.
Alright.
Yes.
Yeah, so you just find marginal utility. and we can go through them together, and that will be the end of today's lesson. Today I'll send you some practice questions. I'll send you one practice question. Basically, I just want you to calculate marginal utility and present the table and the graph. Yeah, that's all. Okay, has anyone found the value so far? Or should I give you a bit more time?
2 more minutes.
Okay, sure.
2 more minutes. Yeah.
D'accord. Okay, so when we finish our lesson, I'll send you this PowerPoint, or maybe I'll make it a PDF, so you can go through it at your own convenience, and also to help you for the calculations I'll ask you to do. So you guys can just let me know when you're done calculating. We'll go through, and we'll be done for today.
J'ai fini.
Okay. What about the others? Are we together?
Yes.
Okay. So, who can tell me the value of the first marginal utility?
The first value of marginal is 10.
Okay. Alright, yeah, you're right. Alex, you can just use your mic to answer, to make it easier. Yeah, so yeah, it's correct. The first value is 10. Did everyone find that?
Yes.
Yes.
Alright.
Yes.
Good. The next value?
The next one is
8.
Voila, exactement. That's correct. And the last value?
6.
6.
Exactly. Good. Okay,
But I have a
that's
question.
good. Oh yeah, go ahead.
How come there is no required dose at it?
In this case. Yeah, this is part of a larger question. It's actually the question that I'll give you. I just wanted you guys to practice how to replace the values, and yeah. So when I give you the full question, you'll find the point du satiété after this point. I think it should be the point right after this third one here, but we'll see. Yeah, so in this case, it was just for practice for replacing the values. Then in the other question, you will encounter it. Is that okay?
Yes.
Yes.
Okay,
Yes.
good. So yeah, that ends our meeting for today. Thank you guys for attending. Thank you for your attention. Quick question. In comparison to the previous lesson, how was this one? Do you think you understood better? Any problems? Anything to improve on?
This class was very excellent.
Thank you.
The class is always awesome, madam.
Thank you. You guys should see me smiling. I'm smiling so much. Best boss luck. Okay, so I'm glad to hear that. I'll be
A suggestion, madam.
Go ahead.
I was suggesting if someone asks a question, why don't you pass it to the fellow students so that we try it then, because we also have maybe wrong answers in ourselves. So
Okay, sure. Yeah, we can do that. We can. I think at every point when someone has a question, I'll ask if someone if one of you guys has an answer, and if it's accurate, then we'll go with that. If not, I'll try to clarify a bit more. Does that work for everyone?
yes.
Yes.
All right, cool. All right, so we'll work that way. Yeah, so that's the end of our meeting. Thank you again for attending. And we'll meet again this Friday. On Friday, we'll have 2 lessons, one in the morning, one in the afternoon. And I think I will finish up this part, and then we'll enter the next section, depending on how you guys understand. And yeah, but I'll be moving at your pace. As long as you understand, then I'll move. If not, we'll stay as long as you need me to. Yeah, so thank you again for attending. You guys have a good rest of your day. Yeah, have a great day. You are
Thank
free
you.
to leave. You're welcome.
Thank you, and same.
Thank you. You're welcome.